We're now going to look at implicit differentiation. And implicit differentiation is really good for when you're trying to take the derivative of an example problem that's going to be in terms of both x and y. So when we look at y in our equation, it's really going to be considered as y of x, so as a function. And so when we look at this example problem, really, when we see this y, it's really going to be y of x. So let's go ahead and take the derivative of this example. X squared plus y squared is equal to r squared, which is the equation of a circle. And so here we have the derivative of x squared, or d dx of x squared, plus d dx of y squared. And we know that this y squared is really just y of x squared, which is going to be equal to d dx of r squared. And we know that this r squared is a constant. So let's evaluate this middle term here. We have the derivative of a function raised to a power. And so we can see that this is really just the chain rule. And so we can go ahead and take the derivative of the outside function. So this 2 will come out in front. We'll leave this inside function alone. So we have y of x. And then we're going to multiply it by the derivative of this inside function, which is going to be represented as y prime of x. And so here we can do our derivative. So x squared is going to be 2x. Our d dx of y of x squared is going to be 2y of x multiplied by y prime of x, or the derivative, which is going to be equal to 0. And this was given by taking derivative of a constant. So we can go ahead and simplify our expression and represent this y prime of x as y prime. And we can solve for y prime by manipulating the 2x to the right-hand side and then dividing by 2y. And here we have our solution. Y prime is going to be equal to negative x over y.